Hi everyone. In today's challenge, we are going to solve this problem. The problem name is peak index in a mountain array, and the problem number is 852. Alright, guys. So first of all, what we are going to do? We are going to clearly understand the problem statement first of all. After understanding the problem statement, then we will move to the logic part. In the logic part, we are going to see how we can solve this problem. What is the logic? What is the algorithms we are going to use to solve this problem? So after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine, guys. And guys, if you want to have a look on the solution, which I'm going to write in this video for Python, C++, Java, and JavaScript, I will share link in the description. You can go through that particular link and you can find all the solution, right? Now, guys, let's see what this problem says. So let's understand the problem statement. So, guys, problem says an array, ARR, a mountain if the following properties hold. So, first of all, an array, right? Array, when an array will be called a mountain? When array of length is greater than or equal to 3, right? So, when array length is greater than or equal to 3, second condition is there exists some I with 0 less than I less than arr dot length minus 1. That means that what between the array length such that array of 0 less than array of 1 less than so on up to array of minus 1. So simple thing, guys, this two line simple says if there is an array which have a more than length 3, right, equal to more than 3. So let's make some array, let's say 2 4 6 8 3 2 0, right? So simple thing, this I have created this array, so each number have a different element, right? Fine, guys. Now there exists some I, means we have to find such index. So here you can see this is 0 index, 1 index, second index, third index, 4 index, 5 and 6. So let's say I is nothing but 3, right? So what should we do? What should be there? So all the elements from that particular index, right, on to the left side from that index should be what in a, we can say, what we can say, we say in decreasing order, right? 8, then less than 6, then 6 less is 4, and 2 is also less than we can say 4, right? So this is in a decreasing order, 8 6 4 2, right? 8 6 4 2, and right side of this particular index should be in an increasing order, right? Not increasing order, I will we can say in a decreasing order only, right? So here you can see this was 8, right? So after that 3 8 3 2 0, this is also in a increasing, we can say decreasing order, right? So we have to find there exists some I which is should be in between of the 0 to 6. They have seen 0 I less than arr dot length of minus 1. So 0 to 6 such that all the index till that I should be in an increase, we can say if you are considering from this 0, then it should be increasing. If you are considering from the index, then it should be decreasing, right? So 2 4 6 8, this is in increasing order, but if you are considering from there, so it should be in decreasing order, that whatever you are want to take it, right? After that, from on the left side also should be the same case. If you are taking from 8, then it should be decreasing order, but if you're taking from the backward 0 2 3 8, it should be in increasing order, right? So this should be the case, right? So we have to find such I, right? So we have seen the condition of a mountain array. So a mountain array will be called when a length is greater than or equal to 3, and second condition is going to be nothing but there should be one I exists where to the left side of these elements of that particular I, so all should be in an increasing order, or we can say decreasing order, and same goes for the right side as well, right? Fine. Given a mountain array ARR, return the index I such that. So now what we need to do? We need to just return this I, right? So here we have to return 3. Why? Because at third index, we know that all the elements on the left side was in a decreasing order. All the element on the right side also was in a decreasing order, right? Fine. So we have to return 3. And you must solve in log of an array dot length time complexity. Now we don't need to solve in just big of n as well. We just need to solve in big of log of n, right? Fine. And there is one more condition. Let me show you on the constraint part. See, guys, the array length will always be greater than or equal to 3, and array is guaranteed to be mountain array. I hope you are getting this. So array is always guaranteed to be mountain array. It's not like we have to check as well whether it's a mountain array or no. No, they're definitely going to be a mountain array, right? So this means the array will always have a length greater than or equal to 3. They have clearly mentioned. And second condition, there will be some I, there will exist some I where the left side of it all going to be decreasing order, right side of it also going to be decreasing order, right? And array value is never be going to be less than 0, right? It always be greater than 0. Fine. Now, guys, we have to see this example 1. So in example 1, we have this array 0 1 and 0. You can easily tell me what is that I where all the elements on the left side are in decreasing order, all the elements on the right side also are in decreasing order. So if I just make an index, this is 0 index, this is 1 index, this is second index. So you can see one index, we know that left side also in a decreasing order and right side also in a decreasing order. So this is nothing but our we can say index where our mounting condition is getting satisfied, right? So I can say return 1. This is the index, right? On the second example, you can see we have this 0 2 1 and 0, right? This is our array. So now let's make some index. Fine. So now what we are going to do, we are going to find, first of all, you know that this length is greater than 3 and it will always going to be, just we need to find one index where the left side of it always going to be decreasing order, right side also we going to be decreasing order. So if we take 0, then you can see this is not a case because it is greater than this, then after that decreasing, right? So if we take 1, then you can see guys all the elements on the left side 2 comma 0, if I'm considering from this, it is in a decreasing order. And we can say here as well, from 2 comma 1 comma 0, it is also in a decreasing order, right? So there exists some I which is nothing but a at index 1. We can say that all the elements on the left side are in decreasing order, on the right side as well are in decreasing order, right? I hope it makes sense. So we just found an index where our all the elements on the right side should be in a decreasing order only, right? And the right side also should be in a decreasing order only. So you can see guys, this is the condition satisfied. So we are going to again answer 1, right? Fine. And then move to the next example where we have 0, 10, 5 and 2. So guys, here also you can see we are getting answer 1 only. Why? Because you know that on 10 we know that now all the elements from this right side are getting decreased, right? 10 is greater than 5, 5 is greater than 2, right? And same goes for here, 10 is greater than 0 and 0 is not greater than anyone because no element exists on the left side now. Fine. So we are going to return again answer 1. So hopefully, or we can say by coincidence all the examples having answer 1, but right. If I take any other example, let's say I take any other example. So now let's understand 13720, right? So what will be the answer here? You can try to find out, right? Answer will be nothing but two, we can say 2 only, right? 0 1 2 3 4. This is the index, so 2, because you can see from the left side 731 decreasing, 720 decreasing, right? Fine. And now let's understand the base condition here. They haven't explained us the base condition, but hopefully you should know, right? So base condition is going to be nothing but, let's say this is array. So what will be our index where that condition is satisfied? So this is the first base condition. So guys, here the answer is going to be nothing but, you can say 0. Does that make sense? Answer is going to be 0, means 0 index. Why? From this index you can see all the elements on the right side are decreasing, all the elements on the left side are also decreasing. Why? Because there is no element exist. But let's suppose there is some going to be elements, so it always going to be decreasing, right? We are assuming it because now at 0 index we know that all the elements on the right side are decreasing, means that condition is satisfied, but there is no left side exit, so we don't need to take care about it, right? And the second base condition is nothing but this one. So tell me guys, here what will be the answer? Here answer will be nothing but 3, right? 0 1 2 3. So third index. Why? Because on the every element on the left side are decreasing, 4 3 2 1, you can see, and right side there is no exit, so we don't need to take care about it, right? So these are two base condition where complete array is in ascending order, complete array is in descending order, right? So when complete array is in descending order, you have to return 0 index. When complete array is ascending order, you have to return third last index, right? So this is a base condition, and you will understand better in the logic part. We are going to see that part as well. So I hope guys you understood the problem statement now. What is the problems want, and what how we can do this, we are going to see in the logic part. But you must have to understand the problem first. So problem says simple in if I say summarize that one. So first thing is nothing, we are given one array only, and that array is definitely or guaranteed as a mountain array, right? So that array always going to have a length greater than equal to 3, and there definitely going to exist an index I where all the elements on the left side are going to be increasing order or decreasing order, and also all the elements on the right side also going to be in decreasing order with respect to that index, right? So I hope it makes sense, right? Now what we are going to do, we are going to say, let's move to the logic part, right? Fine. Now in the logic part, what we are going to do, we are going to take a simple example. So let's take an example of 0 10 5. First of all, think about this, guys. Is this array, whatever the array given to us or will be given to us in any test case, is this have any order? Think about this. Definitely it's going to have an order, right? Why? Because they already mentioned us that it is guaranteed to be a fountain array, or not fountain, mountain array, right? So what is that, what is that meaning? So that meaning is nothing but, we can say all the elements could will be going to be in increasing order, then all the elements could, will be going to be in decreasing order, right? So let's say here it's getting increase and here it getting a decrease. So right, so this is going to be the we can say structure of our array, right? So this is nothing but in order, right? We can use a binary search array. Why? Because we know the order here. Binary search is not apply only for sorting array, right? For sorted array, it applied for ordered array, right? Where you know the order of an array, how array is working. If you know guys, this is a 4, right? So then definitely you know guys, with the next element on the previous element, if it is 4 and if it is greater than the if next element is 6, so definitely you know guys the previous element is always going to be less than 4. I hope it makes sense, right? So in your array, if you have a 4 and 6, right? Let's say you have some element on the left side and you have 4 here and you have 6 here, and this keep going. So what do you know guys here? You know guys, these element on the left side definitely going to be, we can say smaller than the 4, right? Because it is now increasing orders. That means this in this this one phase, right? right? And the same condition, if I take another, so let's say this is 8 and this is 4 and this is nothing but 3, or we can say 6, right? So what are they going to be here? So definitely, you know guys, their element is going to be always less than 6, because now this is in this phase, right? I hope it makes sense. So this was the simple basic condition. I hope guys you understood. I hope this much clear to you. Now let's move to the logic part, not logic, I will say binary search part, how we can use the binary search here. So what we are going to do, we are going to say first of all base condition we are already going to check. Second thing, now what we are going to do, we are going to say start from there, from 0 and go to till length, and just try to find out the index mid. So once we found a mid, and we found that if mid is pointing to 0, then we have to check what? Then we have to check it should be in a decreasing order. If mid is at the end n minus 1, then what we need to check? We need to check it should be in increasing order. And how we can check that? We already know, right? If it is in increasing order, then this element should always be greater than this one. And if it is a decreasing order for 0, this element should be greater than this one, right? Right, this makes sense, right? Now the second condition, if our mid lie in between of this. So first condition, nothing but if our mid is 0, then we have to check array should be in decreasing order. Otherwise, if it is a decreasing order, then return 0. Otherwise, keep move to the right side. And second condition, if mid is equal to the last element, means n minus 1, the array should be in increasing order. And if it is increasing order, return mid. Otherwise, move to the left side. Third condition is nothing but if mid is in between of 0 to n minus 1, right? Now we are going to check. Let's say mid is here. So we are going to check. Let me move all this thing. Now we are going to check. Is it greater than the previous one and greater than the next one? If it is so, then return this mid, because then only the condition is satisfied. So if you assume mid is here, one index, so 10 is greater than 0 and 10 is greater than 5 as well. So we are going to return 1. But if it is not the case, so in that will happen in the 5 case, right? So here on second index, you can see it is greater than the right side, but it is not greater than the left side. So what we are going to do, we are going to move to the left side. Simple thing, move to the left side. So we are going to say move to the left side. And same goes here. If we are at let's say 0, and it is not, you can see it is greater than from the right side, it's not going to happen. So let's insert some element as well. So let's say I'm inserting 2. So let's say we are going to here, right? So we are having a one index. So you can see it is greater than from the left side, it is greater than 0, right? But it is not greater than 10. So we are going to move to the right side. So we have seen three conditions. If it is greater than from left and right, means previous and next element, so return mid. If it is greater than previous one but not greater than the right one, so move to the right side. If it is greater than right one, means next one, but not greater than the previous one, so move to the left side. I hope you're getting these things, just simple thing guys. If you're finding this particular pattern, but and then previous pattern is not following, so you have to move to the previous side, right? So in this case, simple guys, if 5, you can see it is greater than 2, means it is fine, but it is not greater than 10, so you have to move to the right side. And same for 2, if it is greater than 0, right? Fine, but it is not greater than 10, so move to the right side. Simple thing, right? Now let's move to the implementation part, and let's see how we can implement this simple logic, right? So it is not going to take more than 5 or 6 minutes, right? So I'm in a browser. And first of all, what I'm going to do, I'm going to starting with the Python. So let's first of all say find a length. Length is going to be length of ARR, and here we're going to say low is going to be initially 0, high is going to be nothing but n minus 1. While we can say low is less than equal to high, right? Let me take a small low. Low is less than equal to high. So what we are going to do, we are going to say find out mid. Mid is going to be low plus high divided by 2. Right? So I used to do this like binary operation. Fine. So we have divided by 2. Now we are going to check if mid is 0. Then what we are going to do? Think about this guy. If mid is 0, see it should be in increasing order, right? So we are going to say if mid is 0, then check it. ARR of mid is greater than ARR of mid 1. That means ARR of mid plus 1. So this means nothing but if it is the case, then it is written, we have to return mid. Why? Or we can say return 0. Why? Because now it is in a increasing order. Not sorry, it is in a decreasing order, right? So we have to check if it is a decreasing order or not. And if mid is 0 and its condition not satisfied, means it is not a decreasing order. So we have to move to the right side. So what we are going to do, we are going to say else you have to say mid it should be equal to low mid node. I will say low is equal to mid plus 1. Fine. And the second condition is nothing but else if, so we can say, let's say here else if mid is equal to n minus 1, means mid at the end. So what we need to check, we need to check it should be now in increasing order, right? So for increasing order, we can say if mid is greater than AR of mid minus 1, then it will call an increasing order, right? So we can say return mid. But if it is also not in increasing order, but mid is equal to n minus 1, so we can say fine, so move to the left side. So left is going to be high is equal to mid minus 1. Fine. And else the last condition, if mid is not 0, mid is not n minus 1, means it is in between of that. So then what we can do, we can say fine, check first of all if ARR of mid is greater than ARR of mid minus 1 and ARR of mid is greater than ARR of mid plus 1, then fine, you have to return mid. We have already seen this condition, right? If it is greater than from previous and next, so return mid. Otherwise check if L if ARR of mid is greater than ARR of mid minus 1, means it is greater than from mid minus 1, but it's not greater than from the right, next one. It is greater than from the previous but not next one, means right side. So we have to move to the right side. So high low is going to be nothing but mid plus 1. So we can do in just one line. Low is going to be nothing but mid plus 1, right? Else we can say fine, we can say move to the right left side. High is equal to mid minus 1. So this is the simple condition written at the minus 1 if it does not satisfy. So let's see. I hope it should work, right? Let's see that. You can see we got an error. Why? Oh, all right. So this is not a C++ Java, or it's Python. Fine. Now let's see. You can see, guys, all the test case passed. So let's try to submit this code, and it's a simple logic, right? Just we are using a simple binary search, nothing else. So it's always following a log of and time complexity, right? Now, fine. Let's move to the next programming language. Nothing but we can say C++. Here, let's quickly say int n is equal to arr dot size, and we are going to say int low is nothing but we can say 0, and high is nothing but n minus 1, right? And here we are going to say while low is less than, right? Low is less than equal to high, and here we are going to say intermediate is nothing but low plus high. What I'm doing, I don't know. Fine. Here, fine. So we are going to say if mid is equal to 0, first condition, if mid is equal to 0, then what we are going to do, we are going to check if it is in decreasing order or not. So ARR of mid is greater than ARR of mid plus 1. If it is the case, then it is a decreasing order, so return mid. Otherwise, what you are going to do, you are going to say move to the right side. So for right side, we have to say low is equal to mid plus 1. Fine. And else if mid is equal to n minus 1, that means at the end, so it should be in increasing order. So if ARR of mid is less than or not less than, it is greater than ARR of mid minus 1, then it is in increasing order, so return mid. Otherwise we can say move to the left side. So high should be equal to mid minus 1. Else we are going to say else condition, if ARR of mid, you can say simply if ARR of mid is greater than ARR of mid minus 1, and ARR of mid is greater than ARR of mid plus 1, that means it is greater than from previous and the next element, so we can return mid. Else if we are going to say fine, it is not the case, then ARR of mid is greater than ARR of mid minus 1, then we have to move to the right side. Return mid is not return, we have to say low is going to be nothing but mid plus 1. Else we are going to say high should be equal to mid minus 1, right? So we have to move to the, let me write here, we have to move to the left side. At the end, what we can do, we can simply return minus 1, but we know that this is going to be always found in array, but let's return minus 1, right, to avoid the error, because in this function should return at least minus 1. And you can see all the rest is passed. So let's try to submit this code as well, and by this we are going to complete with C++ as well. So left with two programming languages, Java and JavaScript. Fine. You can see, guys, it also got successfully submitted. Now let's move to the Java. And in the Java, what we are going to do, we are going to say initially, let's take it. First of all, find a length, arr.length, and here we're going to say while, first of all, let's define low and high, right? And low is nothing but we can say 0, high n minus 1, right? Let me say n minus 1. We can say while low is less than equal to high, and here we can say intermediate is nothing but low plus high. We can say low plus high divided by 2, and here we can say if mid is equal to 0. So what we are going to say, we are going to say it should be in increasing order. So if ARR of mid is greater than ARR of mid plus 1, so we can say return mid. But if it is not the case, so we are going to say fine else. So you have to say low should be equal to mid plus 1. Else condition, else if mid is equal to we can say equal to n minus 1. So what we are going to do, if mid is equal to n minus 1, if ARR of mid is greater than ARR of mid minus 1, that means it is in increasing order. If it is so, then return mid. Otherwise we can say else high should be mid minus 1. We are moving to the left side. Fine, we have seen both the base condition. Now we are going to say if mid is between 0 and n minus 1, that means we have to check for the left and right side. So we can say if ARR of mid is greater than ARR of mid minus 1, means from the left side, and ARR of mid is less than not less than, it is greater than from ARR of mid plus 1, means from the right side as well. So if it is greater than from the right element and left element as well, so then we have to return mid, then it's following the mountain condition. And else if ARR of mid, if it is not the case, and if it is greater than from the previous one, means the left side, then we have to move to the right side. Return mid minus not return, we can say low should be equal to mid minus 1, not plus 1 by. Fine. And else if it is also not the case, if it is not greater than from the left and right side, and if it is also not greater than from the left side as well, so that means it is greater than from the right side. So if it is greater than from the right side, then we have to move to the left side, right? So high should be equal to mid minus 1. Fine. Now at then we can simply return minus 1 to avoid a error. So we can say return minus 1. Let's see whether it's working fine or no. So I hope it should work, right? So let's see that. So you can see guys, all the tests is passed. So finally let's try to submit this code as well. And I hope guys it will also gonna submit. So let's see. You can see guys it successfully got submitted. Now let's move to the next programming language, nothing but JavaScript, and it is the last programming language. So what we are going to do, first of all, we are going to say let n is equal to arr.length, and then we are going to say low. We can say let low is nothing but 0 and high is nothing but we can say n minus 1. Fine. Then while low is, we can simply low is less than high. First of all, calculate the mid, which is nothing but gonna be nothing but we can say low plus high divided by 1, right? And if mid is we can say first of all mid is 0, then it should be in decreasing order. So if arr of mid is greater than arr of mid plus 1, then we have to say return directly mid, right? But if it is not the case, so we are going to say low should be equal to mid plus 1, move to the right side. Then we can say else if mid is not equal to 0 but it is equal to the n minus 1, when it is pointed to the last element, right? So we can say fine, check if arr of mid is greater than arr of mid minus 1, it is in decreasing order, no, or not decreasing, increasing order now, then we have to return mid, otherwise we have to move to the left side. So we can say else high should be equal to mid minus 1. Fine. And the last condition, if it is in between of 0 to n minus 1, then we are going to say if arr of mid is greater than arr of mid minus 1 and arr of mid is greater than arr of mid plus 1, then you have to what you have to do, you have to return mid. Otherwise check arr of mid, if arr of mid is greater than arr of mid minus 1, then you have to move to the left side, right? So if above condition does not satisfy, so you have to move to the left side, and if this is also not satisfied, then you have to move to the right side. And I know I have done one mistake, let me just correct that as well. So I have to write else if, right? Fine guys, so we have write else if, we can't write, we don't need to write as well if because we are using a return statement here. If this condition is satisfied, so it will directly return, right? But let's see, right? Now at then what we can do, we can simply return minus 1. Now let's run this code and see whether this working fine or not, and I hope guys it should also work, right? And you can see all the rest cases are getting passed. So let's try to submit this code as well, and definitely you will also want to submit, right? You can see it's successfully got submitted. So we have successfully done the implementation with Python, C++, Java, and JavaScript. I hope guys you understood all the implementation. If you have any kind of doubt in the problem understanding part, logic part, implementation part, you can write it easily in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.